In this video, I want to show you how we can use a squeeze theorem to show that this limit equals 0. First, let me show you that with direct substitution, we cannot find this limit. If we want to find this limit with direct substitution, the problem that we have is that if we plug in 0 for x, the limit of this is 0. 0 to the 2 plus 3 times 0 is 0. So limit of the bracket is 0. But attention, limit of sine of 4 over x when x approaches 0 does not exist, because in numerator we have a number, in denominator we have x, and x approaches 0. A number over 0 approaches infinity. So this fraction when x approaches 0 goes to infinity. And we know that sine of infinity or cosine at infinity does not exist. So we cannot find this limit with direct substitution. And so we have to use a squeeze or sandwich theorem to find this limit. For finding these type of limits using sandwich theorem or squeeze theorem, we start from the part of the limit that involves trigonometric function. In this case, it is sine. Usually the trigonometric function is sine or cosine. If we use our knowledge from pre-calculus for sine and cosine, we remember that sine of any angle, like sine of theta, and theta can be anything, or cosine of theta is always between -1 and 1. And it doesn't matter what is theta. For example, theta can be x to the 2, 1 over x, pi over x, any expression in terms of x. For any value of theta, sine and cosine are always between -1 and 1. And it's because if you remember graph of sine, it oscillates up and down. It goes up and down between -1 and 1. So always sine and cosine oscillate between -1 and 1. So for this reason, when we want to find these type of limits, we start from this part of the limit and we use our knowledge and we say sine of 4 over x is always between -1 and 1. And now we want to make this expression like this expression in the limit. If you pay attention, to make this expression like this expression here, what we have to do? We have to multiply this expression by x to the 2 plus 3x. Because attention, we want to find limit of all of this expression. So far we know that sine of 4 over x is between -1 and 1. To make this like this expression here, we have to multiply both sides of this inequality. We have to multiply left side, the middle part, and the right side of this inequality with x to the 2 plus 3x. So, because we want to convert this to this expression, we decide to multiply both sides of this inequality by x to the 2 plus 3x. But what makes this question tricky is that if, like many other examples, immediately we multiply the left side, this and this, by x to the 2 plus 3x, then this is a mistake. Let me tell you the reason. The reason is about this expression, that we want to multiply both sides by that expression. The thing that you have to notice is that x to the 2 plus 3x, when x approaches 0, can be either negative or positive. You know that when x approaches 0, x can approach to 0 from the left or from the right. When x approaches 0 from the right, x is a number, a small number, close to 0 but positive. When x approaches 0 from the left, x is a small number that approaches 0 but from the left, so x is negative. When x approaches 0 from the right, this expression x to the 2 plus 3x is positive. When x approaches 0 from the left, x to the 2 plus 3x is less than 0. It's negative. And because when x approaches 0, we don't know x approaches 0 from the left or right. Basically, it approaches to 0 from both sides because this is a two-sided limit. So we have to find this limit once from the left, and we have to find the limit from the right. Because when x approaches 0, x to the 2 plus 3x can be either positive or negative. And we know that if we want to multiply an inequality by an expression, we need to know the sign of that expression. If the expression is positive, multiplying both sides of an inequality by that expression doesn't change the inequality. But if the expression is negative, we have to change the direction of inequality. And so we have to find, for finding this limit, we have to find limit of this expression once when x approaches 0 from the right, once when x approaches 0 from the left. And let me clarify this for you. Why when x approaches 0 from the left, this expression is negative? Because x to the 2 plus 3x is basically x times x plus 3. X times x plus 3. When x approaches 0 from the right, x is positive, and of course x plus 3 is also positive. So this expression is positive. But when x approaches 0 from the left, the x is negative, and x plus 3 is positive. Negative times positive is negative. And also you can check this by a number. For example, you can test a number close to 0 but less than 0, like negative 0.1. If you plug in this number for x in this expression, simply you can see that this expression is negative. So for finding this limit, we have to find limit once from the right and another time from the left. So let's do it. So we consider two cases. If x approaches 0 from the right, then x to the 2 plus 3x, which is basically x times x plus 3, is greater than 0. And so if we multiply both sides of this inequality by this expression, the inequality, the direction of the inequality doesn't change. So basically by multiplying, we have negative x to the 2 plus 3x in the left. In the middle we have x to the 2 plus 3x times by sine of 4 over x, and by multiplying the right side by this expression, we have x to the 2 plus 3x here. Now we have to find the limit of the function in the left and the function in the right. If the limit of these two is the same, then the limit of the middle function is also that value. What is limit of negative x to the 2 plus 3x when x approaches 0 from the right? With direct substitution, you can find this limit. Plug in 0, then the limit is 0. What about limit of the other side? What is limit of x to the 2 plus 3x? What is the limit of this when x approaches 0? It is also 0. Now from these two limits that are 0, we say from Squeeze Theorem, we can conclude that limit x approaches 0 from the right of the middle function, which is trapped between this function and this function, between these two functions, should also be equal to 0. And it's completely should be clear for you. The limit of the left function is 0. Limit of the right function is 0. So this function is between them. So the limit of that function should also be 0. It should be completely clear for you. Now let's consider the other case. If x approaches 0, now we consider when x approaches 0 from the left. When x approaches 0 from the left, x to the 2 plus 3x, which is basically x times x plus 3, is less than 0. Again, let me explain you why this happens. When x approaches 0 from the left, x is a small number close to 0 but negative. This means that x is a negative number close to 0. Because x is close to 0 and negative, x is negative. But x, which is a small negative number, plus 3 would be positive. Negative times positive is negative. So in this case, the expression that we want to multiply both sides of this relation by that expression is negative. So when we multiply both sides of this relation by this expression, we have to flip these inequalities. We have to change the direction of the inequality. So by multiplying by x to the 2 plus 3x, we have negative x to the 2 plus 3x, not less than equal, greater than equal, x to the 2 plus 3x, sine of 4 over x, greater than equal, x to the 2 plus 3x. So here we had negative 1 less than equal. Now we have flipped the inequality and it is greater than equal, as you can see. Again, we have to find limit of the left function, limit of the right function. If the limit of these two is the same, the limit of the middle function is also that number. Limit of negative x to the 2 plus 3x when x approaches 0 from the left is 0. And you can find this by direct substitution. Plug in 0 and it is 0. What about the other limit? Limit of x to the 2 plus 3x when x approaches 0 from the left is also 0. So from Squeeze theorem, we can conclude that the limit of the middle function when x approaches 0 from the left is also 0. So far we have shown that limit from the right is 0, limit from the left is 0. We know that if the limit from the right is the same as limit from the left, then the two-sided limit exists and equals same number. So by combining relation 1 and relation 2, by considering these two from 1 and 2, we can conclude that limit x approaches 0 of x to the 2 plus 3x times sine of 4 over x is 0. And this completes the solution of this tricky question. Usually when we want to use a squeeze theorem, this expression when x approaches 0 is always either positive or negative, and we don't need to consider two cases. The thing that makes this question really tricky is that we have to consider basically two cases for finding this limit. We have to find the limit from the left and we have to find limit from the right, and then finally we can find the limit of the function.